So we learned from example 5 that we can use the vertical line test to tell whether a graph represents a function or not. How can we tell if an equation represents a function? Well, in that situation, we're going to want to solve for y and then determine whether we would only get one value for y for each value of x in the domain. And so let's solve this one for y. So we're going to subtract x squared from both sides of this equation, and that's going to give us y is equal to negative x squared plus 4. So if I picked a value of x, and let's just talk about what is our domain. Well, this is a polynomial. We're not dividing by something that's got x or a variable in the denominator, and so since it's a polynomial, then we can use anything for x. And so now let's determine whether when we plug anything in for x, are we going to get more than one value for y? Well, let's try and see. So we could plug in 0, we're just going to get 4. If we plug in 1, we're going to get 1 getting squared, and subtract 1 from 4, just 3. So no, we're going to be fine. We're only going to get, so not no, but yes, we're going to be fine. This one's a function because we're only going to get one value of y for each value of x that we put in there. Let's try b and see what happens. Let's see, we got to get y by itself. So we'll start out by subtracting x minus 3 squared from both sides of the equation. In parentheses, that is. And so that's going to give us y squared is equal to, we can just go ahead and put 16 minus x minus 3 quantity squared. And so now we don't have y by itself yet. We need to take the square root of both sides. So when I take the square root, when it's my idea to take the square root, I need to remember that I could have had a positive number or I could use a negative number. And so we've got to put plus or minus on the on this side on the right. And so we're going to have y is equal to plus or minus the square root of 16 minus x minus 3 getting squared. So in here, first of all, we've got to make sure we're not going to put anything in for x. It's going to give us something that's negative inside here, but 0 certainly works. So let's try 0. If we take 0 minus 3, then that's going to give us a negative 3. We're going to square that and get 9. 16 minus 9 is going to give us 7. And now we're going to have y is going to be plus or minus the square root of 7 just with one value of x that we put in. And so even 0 proves to us that this is not a function. Okay, so that one would be a no. This one would have been a yes. Okay, so the last part of this lesson 2.2 is just, I wanted to just show you some of the graphs that we're going to be using a lot in this book. So you can get a copy of this from page 166 in your book. What you have in your notes, it doesn't print very clearly because it's really hard to snippet an entire page and expect to have that come out looking decent. And so that's why it looks pretty fuzzy. But I do want to point out to you that the two graphs that I highlighted in the root functions down here, f of x is equal to the nth root of x, there's two of them where our function is not even defined where x is negative. It's only defined when x is greater than or equal to 0 because this is the square root, meaning the 2, n is 2, and this is the fourth root. And so anytime our root is even, then we're going to find that it's not defined over here where x is going to have a negative value because it's not defined for negative values when we're working with only real numbers. And so we're going to have linear functions, power functions, f of x is x to the n, root functions, reciprocal functions we'll be working with sometimes, and absolute value functions, and even maybe the greatest integer function. So these you can all find on page 166.